Now, what I wanted to look at here is something called Newton's laws. And these laws are very similar to Descartes, but we've got some different ways of looking at things. And you do have to know about this as well. So let's just start with and I'm just going to draw these roughly so that you get an idea what's going on. This is the converging lens. And we had our focal points, and what we found was the two images as usual. But what we've now got is a different couple of units. We've still got SI and we've still got F, and now we've got an SI and an SO. So the big question is, what's SI and SO? So we get three new formulas, and they are that, let's just have a look here. I'll just go off our homework sheet so I do them the same way. We've got that one. That's the main one. But we've also got magnification is equal to F over SO, right? Which is equal to SI over F. And so three main formulas. M equals F over SO, which equals SI over F, magnification. But what is SI and SO? Those are the same things that you need to memorize. So we're now measuring from the focal point and not from the lens or mirror, which we do with Descartes. So we're measuring from the focal point. And we've got to learn where we measure from. So with the converging lens, SO is from this focal point. That's SO, from the focal point on the side of the object. All right, and SI is from the focal point on the side of the image. All right, but, and that may be all very simple, but what about when you've got a diverging lens? Well, when you've got a diverging lens, all right, your SO is from this side, and this is all based on having an object on the left. And I just said, when you've got an object on the left with a converging lens, all right, with a converging lens, your SO is from this focal point. Object is on the left, so over here. Doesn't matter whether it's there or whether it's here. With the converging lens, your SO is measured from this focal point, and your SI is measured from that focal point, which means when you get that virtual image, when you get this object in here, then your SI is still measured from this lens, but it crosses all the way over here, and your SO would just be that distance. So you get the three images. It's not that hard to do. Just remember that with the converging lens, SI is measured from this one, and SO is measured from this one, even when you've got the virtual image. So then you get the diverging lens, which is this one, where again, we've got the object on the left. So we've got the object left, and this time, this is what makes it a bit confusing. The object is left, but because everything's round the other way, SO is measured from this one, and SI is measured from this one. So you've got to measure across from SO to your object, which is on the left. Your image will be on the left because it's a virtual, all you get is the virtual image with this type of lens. So getting these SIs and SOs around the right way is mainly what I'm talking about here. With this one, converging, SO is from that focal point, SI is from that focal point. Even when you've got a virtual image, you have to cross right across. With the diverging lens, it's round the other way. SO is measured from the right-hand one, and SI is measured from the left-hand one. And that's with an object on the left. Now let's have a look at our mirror situation for SI and SO, because we can do that. Now the problem, of course, with the lenses that I just discussed was because we've got two focal points. With a concave mirror, we've only got one focal point. So although this produces two types of images, it's very easy to measure to our object, which is our SO, and it's very easy to measure to our image and find our SI. Even though with the concave mirror we can have a big image at the back, a virtual image, we're still measuring our SI across the mirror like that, and our SO was really easy. Of course, to get that virtual image you'd actually have to have your object there, but the distances SO and SI are like that, and obviously if it's a real image it's even easier. So the SI and SO in the mirrors is much easier because you've only got one focal point. So coming back to the convex mirror, we've got again just one focal point. So with that one, again, it's very easy to figure out your objects over here. SO must be that one because there's only one focal point, and your little virtual image, your SI is going to be real easy. So I consider that the only tricky bits with this whole SI-SO bit are the diverging lens. When you've got an object on the left, you measure from the focal point on the right as your SO and your SI on the left. The converging lens is easier because object left, you measure from the focal point on the left for SO and on the right for SI. Alright, that's Newton's laws, SI and SO, and of course once you get these measurements right, everything should work out for the SI times SO equals F squared, and the same for the magnifications. Alright.